So in simplifying rational expressions, which rational meaning kind of looks like a fraction, so we have a numerator and denominator. So to simplify, what we do is we look for common factors that we can cancel out. Since if we have a common factor in the numerator and denominator, well, the same thing divided by itself turns into a 1. So we get these cancellations occurring. Now, when looking for these factors, something we're going to need to use is our skills of factoring. So first thing we'll want to do is completely factor the numerator and denominator, and then look for any common factors. So for example, here I have this x plus 2, and then this denominator here, this x squared plus 6x plus 8, I want to go ahead and factor that. So I'm going to have this x plus 2, and then looking for numbers that multiply to 4 and add up to 6, that's going to be an x plus 2 and an x plus 4. Now, something that I'm going to emphasize throughout these videos with rational expressions is that when we have addition, subtraction between terms in the numerator or denominator, we're going to have these parentheses. Our parentheses are clear down here because we have multiplication. Where it's not clear is in the numerator. There are really these parentheses that group those pieces together because those terms are stuck together with addition. So where we're going to emphasize this is we want to be careful of canceling things that we shouldn't when we have addition and subtraction showing up. But if we keep remembering these parentheses, then I can really see, okay, this is a whole factor here. So the only way to cancel out this x or the 2, it has to be canceling out this x plus 2 as a whole. So the only way I could cancel out things with this numerator is if I see x plus 2 in its entirety, which I do in the parentheses in the denominator there. So it's like dividing those turns into a 1, but how we'll see it is through kind of cancellation. And when they divide, they create a 1. So in our numerator there, if we don't have anything left over, then we'll have 1 as a placeholder over, and then we have x plus 4. And then the only way we could have anything else cancel out is if we saw this whole x plus 4 in the numerator, which we don't. So this would be our final answer from simplifying our original rational expression, and we end up with another rational expression. All right, so let's try this out. So first step, we're going to be factoring. And if it helps, you can do this on the side. Just take 4x minus 4 off to the side and factor x squared minus 3x plus 2 and factor, and that works great. In fact, I'll do that for this first example and then some future examples. I'll just do it all together. So I'm going to separate some side work here. So if I have 4x minus 4, so factoring, there's a common factor of 4. So that would be the same thing as 4 times x minus 1. Now just look and make sure that that's completely factored, which it is. So in my next step with the numerator there, I'm going to change that to a 4 times x minus 1. Now for the denominator, what I'm going to do is take that x squared minus 3x plus 2 and factor that. So I'm going to factor to two pieces, two numbers that multiply to positive 2 but add up to negative 3. So that's going to be a minus 1 and a minus 2. So that factored form is what I can replace with in the denominator, x minus 1, x minus 2. So now I can see in parentheses I have this x minus 1 and I have the same x minus 1 in the numerator as well. So those two pieces can cancel out so that we're left with 4 in the numerator and x minus 2 in the denominator. Now, you might be tempted to divide here, that 4 and 2, but what we need to emphasize is because there's subtraction right there, really that 2 is stuck. And if you need to write these parentheses, I even suggest it. If it helps you from canceling things out that you shouldn't, then think of those parentheses, because the only way that we can get to that 2 there is if we see this entire x minus 2 in the numerator. So it's all because of addition, subtraction, that pieces get kind of stuck together. So with that will stay like that as an answer, as 4 divided by x minus 2. In this next example here, notice there's no addition or subtraction in the numerator denominator, and when those are not present, there's a lot more freedom in terms of what we can do for canceling. So like the 12 divided by 3, that's just equal to 4. So numerically I'll have 4, and then I have this x squared over x piece. Now x squared over x, we can use our exponent rule of it would be a 2 minus 1. Really, we'll just have a single x value left over in the numerator, so that's going to simplify to 4x. And we're done. So we don't really need to worry about factoring there. We don't need to be cautious about what we can cancel and what we can't, because really this is just a big string of multiplication and division, which works really well together. Now here we have a whole bunch of multiplication, but then we also see our addition subtraction pieces, but they're grouped in their parentheses. So this is all in its factored form. So what we could do first is just focus on the numbers. So 8 divided by 10, so there's a common factor of 2 there. So 8 divided by 2 is 4, 10 divided by 2 is 5. So let's see, I'm going to go ahead and draw my numerator denominator, but we're going to have 4/5. And then we could just look for matching pieces. So y plus 1, y minus 1. So those would cancel with each other. Y minus 2, y plus 2, since those aren't exactly the same, those can't cancel out, but the y plus 5 values can. So we're going to be stuck with a y minus 2 times y plus 2. Now with this, and we can do this in multiple stages, but when you get here, just double check in its factored form. That's what this form would be called here. So in this factored form, is there anything to cancel? Which there isn't. We could leave it in this factored form, or we could simplify it out by multiplying. So like this would be the same as 4y minus 8 over 5y plus 10. And then just know we can't cancel anything out, like that 8 divided by 10 there, can't do anything with that because of those hidden parentheses. That 4y minus 8 is stuck together, so we can't divide anything out from there. The only thing we could divide out is a 4, but as we saw in this factored form, nothing cancels. So if nothing can cancel in this factored form, nothing's going to cancel in this multiplied out form. All right, this last piece here, got some good factoring review to do here. So we could do this as side work, or if you want to do it all in one step, you can do that. But with this, let's do some review of our AC method. So we're taking this 2y squared plus 7y minus 15. So basically my next step here is to get numerator denominator, but in factored form. So as a review of our AC method, so we would take 2 times negative 15, which is negative 30. And then I would look for factors of negative 30 that add up to 7. So I'm thinking the 10 and 3 will be a good pairing. So either positive 3 with negative 10 or negative 3 with positive 10. So that first pair would add up to negative 7. So close but not quite, but negative 3 plus 10, perfect. So those two values are going to help me split up my middle term there. So I'm still going to have 2y squared. I'm going to have a negative 3y plus 10y, and then that minus 15 at the end. And then I can factor by grouping. On the left-hand side, there's a common factor of y, and then we would have 2y minus 3 left over. On the right-hand side, there's a common factor of positive 5, and we would have 2y minus 3 left over. So we could factor out that 2y minus 3, and then we would have y plus 5 there. Now just make sure that's all completely factored, which it is. So now my numerator, I'm going to write as 2y minus 3 times y plus 5. And then I'm going to do the same exact thing, but with the denominator. 4y squared minus 4y minus 3. So a times c, 4 times negative 3, which is negative 12. Now I want two values that multiply to negative 12, add up to 4. Thinking 6 and 2, let's see, 2 and negative 6, or negative 2 and positive 6. So 2 minus 6 is -4, so that's what we want. I always write, if I know one's going to be positive and one's going to be negative, I write them both out just because that's a spot where if you move too quickly, it'll change everything. So I always write both of them out and then just take that time to really think about which is going to give you the correct symbol when you add them up. All right, 4y squared, and then we'll have a positive 2y and a minus 6y, and then that minus 3 at the end there. So factoring by grouping, on the left-hand side we have a common factor of 2y, and that would leave a 2y plus 1. On the right-hand side we'd have a common factor of -3, which would leave us with a 2y plus 1. So factor out 2y plus 1, and that'll leave us with a 2y minus 3. So in the denominator, we're going to have 2y plus 1 times 2y minus 3. And now we can just focus on this and look for any values that can cancel out. And what we can see is this entire 2y minus 3 in the numerator and denominator. So those will cancel with each other. And what we'll have left over is y plus 5 over 2y plus 1. So that's our simplifying rational expressions. It's all about getting to that factored form and making sure it's completely factored, and then from there reducing down to the simplest version of that rational expression.